Imagine standing on the top rung of a ladder nearly 10 meters above the ground. Beneath your feet, only a few kilograms of metal hold your entire weight. It feels effortless, almost impossible. But here's what nobody tells you. Before that ladder ever reached your garage or construction site, it traveled thousands of kilometers and survived some of the hottest industrial processes on Earth. Today, you're about to witness the incredible journey of how an aluminum ladder is made. Most people see an aluminum ladder as nothing more than a simple household tool. Yet every rung must support enormous forces while remaining incredibly light. Engineers calculate every millimeter, every curve, and every joint because even the smallest flaw could become dangerous. And this is where the story becomes far more fascinating than you might expect. What happens next surprised even experienced engineers. A finished ladder may weigh less than 10 kilograms, but producing it requires giant mining machines, powerful refineries, precision robots, and quality tests strong enough to simulate years of hard use. By the end of this journey, you'll never look at a ladder the same way again. Every aluminum ladder begins with an ordinary-looking reddish rock called bauxite. The world's largest supplies come from Australia, Guinea, China, Brazil, and India. Australia alone produces more than 100 million metric tons every year. Imagine mountains slowly disappearing. Not for gold or diamonds, but for the lightweight metal hidden inside this humble ore. Massive hydraulic excavators scoop up the ore and dump nearly 100 metric tons into haul trucks in a single load. The engines roar across dusty roads as each truck carries its cargo toward crushing facilities. Every day, thousands of tons begin this journey, moving farther from the mine and one step closer to becoming the ladder you trust with your life. The crushed ore travels by conveyor belts, railways, and giant cargo ships. Some shipments cross more than 15,000 kilometers before reaching an aluminum refinery. Think about this. The ladder sitting quietly in your home may have started its journey on another continent years before you ever bought it. Inside the refinery, crushed bauxite mixes with hot sodium hydroxide solution at temperatures between 140 and 270 degrees Celsius, or 284 to 518 degrees Fahrenheit. This powerful process dissolved the valuable aluminum compounds, while leaving unwanted minerals behind. The thick slurry bubble steams and hisses as chemistry quietly separates the treasure from the waste. After filtration and cooling, the liquid produces tiny white crystals called alumina. These brilliant white particles contain more than 99% aluminum oxide purity and serve as the essential ingredient for metal production. Although they look like ordinary powder, they represent weeks of mining, transportation, and chemical refining. Now comes one of the hottest manufacturing stages anywhere in the world. Alumina enters enormous electrolytic reduction cells operating at around 950 degrees Celsius, or 1,742 degrees Fahrenheit. Electricity stronger than what thousands of homes consume every day tears oxygen away from aluminum atoms, leaving behind pools of glowing molten aluminum. The heat feels overwhelming, and the bright orange light floods the entire building. Fresh aluminum alone isn't enough for a strong ladder. Manufacturers carefully blend magnesium and silicon into molten metal to create alloys such as 6061 or 6063 aluminum. These alloys deliver the perfect balance of strength, corrosion resistance, and lightweight performance. Without these tiny additions, the ladder would bend far too easily under heavy loads. Before a single ladder takes shape, laboratories test every batch with spectrometers capable of detecting alloy variations measured in fractions of percent. If the chemistry drifts outside strict limits, the entire melt gets corrected before production continues. Most people never think about this, but the ladder's safety begins long before any rung exists. And next, you'll see how rivers of molten aluminum transform into the perfectly straight rails and rungs that make modern ladders possible. And this is where it gets truly extraordinary. A glowing river of molten aluminum, hotter than lava at nearly 700 degrees Celsius, 1,292 degrees Fahrenheit, flows slowly into heavy steel casting molds. Within minutes, the bright orange liquid cools into massive cylindrical billets weighing between 500 and 2,000 kilograms. It's hard to believe that these giant metal logs will soon become lightweight ladders you can carry with one hand. The billets don't move straight to production. Giant homogenizing furnaces heat them to about 560 degrees Celsius, 1040 degrees Fahrenheit, for 6 to 12 hours. This long soak allows the alloying elements to spread evenly throughout the metal, creating consistent strength from the center to the outer surface. What happens next surprised even experienced engineers, because one tiny difference in temperature could change the entire ladder's performance. Now the real transformation begins. A hydraulic extrusion press producing nearly 35 to 50 meganewtons of force, or more than 7 million pounds of pressure, pushes each heated billet through a precision steel die. The aluminum flows almost like toothpaste, emerging as perfectly shaped ladder side rails and hollow rung profiles. The machine groans under unimaginable force while the fresh metal glides forward in one continuous motion. The newly extruded profiles travel along a cooling table nearly 50 meters long. Powerful fans blast air across the hot aluminum until it drops below 60 degrees Celsius, 140 degrees Fahrenheit. The metal contracts with incredible precision, and laser sensors constantly measure every millimeter to prevent distortion. You can hear the rushing air, the steady hum of motors, and the occasional metallic click as each profile settles into shape. Next comes stretching. Massive hydraulic grippers clamp both ends of every profile and pull with carefully controlled force, extending the metal by about 1 to 3%. This removes internal stresses left behind during extrusion and guarantees perfectly straight rails. Imagine pulling a piece of soft clay until every tiny twist disappears. That's exactly what these machines achieve with solid aluminum. Computer-controlled precision saws spinning at nearly 3,000 revolutions per minute cut the rails and rungs to exact lengths in just a few seconds. Their carbide blades slice through aluminum so cleanly that the edges need very little finishing. Tiny silver chips scatter across collection trays, while robotic arms move each piece toward the next station with incredible speed. Before assembly, every component enters a solution heat treatment furnace at approximately 530 degrees Celsius, 986 degrees Fahrenheit. Workers then quench the hot aluminum with water in only a few seconds. The sudden cooling locks the alloy into a stronger internal structure, almost like freezing a perfect crystal pattern inside the metal. Steam erupts everywhere as thousands of liters of water meet glowing aluminum. The parts now spend 6 to 10 hours inside aging ovens maintained around 175 degrees Celsius, 347 degrees Fahrenheit. During this stage, microscopic strengthening particles form throughout the alloy, dramatically increasing its hardness. You can't see these tiny changes, but they make the difference between a ladder that bends and one that safely supports hundreds of kilograms. Now the factory starts looking familiar. Automated drilling machines create perfectly aligned mounting holes with positioning accuracy better than 0.1 millimeter. Multi-axis CNC machines shape hinge pockets, locking slots, and stabilizer mounts, while high-speed spindles rotate between 8,000 and 15,000 revolutions per minute. Every movement feels almost choreographed, with dozens of machines working together like musicians in a giant orchestra. Assembly begins as robots and skilled technicians insert the ladder rungs into the side rails. Depending on the design, hydraulic presses apply forces exceeding 20 tons, while industrial riveters squeeze each joint with several thousand pounds of pressure. Every connection must remain perfectly square, because even a tiny misalignment could affect stability years later. Finally, the ladder receives its finishing touches. Workers install anti-slip rubber feet, locking mechanisms, hinges, spreader bars, warning labels, and protective end caps. Powder coating, when required, cures inside ovens at around 190 degrees Celsius, 374 degrees Fahrenheit, creating a durable finish that resists scratches and corrosion for years. The smell of freshly cured coating fills the air as each completed ladder rolls toward inspection. At this point, the ladder looks complete, but appearances can be deceiving. Before anyone is allowed to climb even the first rung, engineers must prove that every single ladder can survive forces far beyond normal use. The next stage reveals a hidden technology that separates an ordinary ladder from one trusted around the world. Most people think the hardest part of making a ladder is shaping the metal. But here's what nobody tells you. The real challenge is proving that every ladder deserves your trust. A single hidden crack, barely visible to the human eye, could grow larger after thousands of climbs. That's why every finished ladder enters one of the most demanding quality control systems in modern manufacturing. The first stop belongs to AI-powered vision systems. High-resolution cameras capture thousands of images every second, while intelligent software compares every rail, rung, rivet, and hinge against an ideal digital model. Even scratches smaller than 0.2 millimeters, tiny dents, or slight color differences trigger an automatic warning. What looks perfect to us often looks completely different to a machine. Next, precision laser scanners sweep across every surface. They build a three-dimensional map accurate to about plus or minus 0.05 millimeters, checking that every rung sits exactly where it should. If one rail twists even slightly during production, the computer detects it immediately. Imagine measuring an object more accurately than the width of a single human hair. That's the level of precision happening here. Then comes a load test. Powerful hydraulic machines slowly apply forces far beyond normal working conditions. Many professional ladders rated for 150 kilograms, or 330 pounds, must successfully withstand test loads exceeding 375 kilograms, nearly 825 pounds, without permanent deformation. Steel frames groan, hydraulic pumps hiss, and every sensor watches for the smallest movement. But strength alone isn't enough. Robotic climbing machines repeatedly step up and down the ladder, simulating years of daily use. Some factories perform more than 50,000 climbing cycles, checking whether hinges loosen, rivets shift, or locking mechanisms wear out. The steady rhythm echoes through the testing hall hour after hour, almost like a giant mechanical heartbeat. Environmental chambers create conditions that nature would normally take years to produce. Some ladders spend hundreds of hours inside salt spray chambers to simulate coastal air, while others face freezing temperatures below minus 30 degrees Celsius, minus 22 degrees Fahrenheit, followed by intense heat above 70 degrees Celsius, 158 degrees Fahrenheit. If corrosion appears too early or moving parts begin to stick, production engineers immediately investigate the cause. One of the most fascinating inspections happens without touching the ladder at all. Ultrasonic testing sends high-frequency sound waves through the aluminum, revealing hidden internal cracks or tiny air pockets trapped inside the metal. The computer instantly converts invisible echoes into colorful images that engineers can understand within seconds. It's almost like giving solid aluminum an X-ray. Despite all this automation, one critical inspection still depends entirely on human experience. Skilled technicians slowly open and close every hinge, test each locking mechanism by hand, and listen for tiny sounds that sensors sometimes miss. A faint click, slight vibration, or unusual resistance can reveal a problem before any computer notices it. Even in one of the world's most automated factories, human instinct still matters. Only after passing these inspections does a ladder receive certification labels that comply with standards such as EN 131, ANSI, or OSHA requirements, depending on its destination. In many factories, fewer than 2% of ladders require rework, and less than 0.5% fail final inspection completely. Those numbers may sound small, but they represent thousands of products carefully removed before reaching customers. The journey isn't over yet. One ordinary-looking aluminum ladder now carries the weight of global mining, extreme heat, precision engineering, advanced robotics, and countless quality checks. But just how many of these ladders does the world build every year, and which countries lead the industry? The answer is far bigger than most people ever imagine. Now that you've seen every step, think about the incredible scale behind something as ordinary as a ladder. Manufacturers around the world produce tens of millions of aluminum ladders every year, supplying construction companies, factories, emergency services, electricians, painters, and millions of homeowners. The global ladder industry generates well over $5 billion annually, and demand continues to grow as cities expand and infrastructure projects multiply. What seems like a simple tool has become an essential part of modern civilization. China leads global aluminum ladder manufacturing with an estimated 35 to 40% of worldwide production. The United States follows with a strong domestic manufacturing base, while Germany, Japan, and India remain major producers known for engineering quality and industrial innovation. Together, these 5 countries manufacture the majority of the world's premium aluminum ladders. Every day, thousands of shipping containers leave their ports carrying ladders to nearly every corner of the planet. Behind every ladder stand an enormous workforce. Mining crews extract the bauxite. Refinery operators transform it into alumina. Smelter workers manage rivers of molten aluminum, while engineers, machinists, robotic specialists, quality inspectors, logistics teams, and maintenance crews keep production moving around the clock. Altogether, hundreds of thousands of people worldwide contribute directly or indirectly to the aluminum ladder supply chain. The story of aluminum ladders stretches back more than a century. Early ladders relied almost entirely on wood, making them heavier, less durable, and vulnerable to moisture. During the second half of the 20th century, advances in aluminum alloy technology transformed the industry forever. Stronger alloys, precision extrusion, and automated manufacturing turned ladders into lighter, safer, and longer-lasting tools that millions now depend on every day. Did you know that aluminum can be recycled again and again without losing its essential properties? Recycling aluminum uses up to 95% less energy than producing new metal from bauxite. That's why many modern aluminum ladders already contain a significant percentage of recycled material, reducing both energy consumption and carbon emissions. Most people climb a ladder without realizing it may have lived several different lives before reaching their hands. Here's another surprising fact. Although aluminum weighs only about 1/3 as much as steel, advanced alloys allow many professional ladders to support 150 to 170 kilograms, and specialized industrial models can safely handle even greater loads. That remarkable balance between lightweight and strength explains why emergency responders, aircraft technicians, and utility crews trust aluminum every single day. And here's one final fact that surprises almost everyone. Engineers already use artificial intelligence to optimize ladder designs before a single piece of metal is manufactured. Computer simulations test thousands of load combinations in just a few hours, helping designers remove unnecessary weight while making the ladder even stronger. Over the next decade, smarter alloys, digital twins, and even more advanced robotics will reshape factories in ways we're only beginning to imagine. From dusty bauxite mines to glowing smelters, from giant extrusion presses to robots measuring fractions of a millimeter, you follow the complete journey of an aluminum ladder. Every rung represents science, precision, and the dedication of countless skilled people working together across the globe. The next time you climb one, you'll know you're standing on far more than metal. You'll be standing on decades of engineering knowledge, relentless testing, and extraordinary craftsmanship. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.